Um, Thank you all again for being here. I know it's a long morning. There'll be coffee soon, so I'm the last one between you and coffee. So I wanted to introduce this idea of using eyes and ears of fish to estimate the contribution rates of different estuaries to adult stock. Big shout out to the funders and collaborators and co-authors on this project. And moving on, now you're going to be so, you're going to be able to know this life cycle off the back of your hand by today. There's going to be lots of it. But basically, we've got lots of movement between feeding grounds and spawning grounds and the adults. And we're now pretty good at kind of understanding this through all the electronic tagging that Kieran was talking about and Matthew was talking about later. So we're getting good at understanding that kind of connectivity there. Now, through the work that Jenny and others are doing, we're also getting better at understanding what happens to those eggs after they're released, where do they end up, and so on. And big shout out to a very muddy Tom Stamp. We're now also getting much better at understanding the movement of those sub-adults, kind of within estuaries, between estuaries, and so on. So we're getting some really great information. But you cannot put one of those acoustic tags on a newly settled group 0 sea bass. They're like less than 2 centimeters, right? So there's still some of these gaps that we want to be able to fill. So we want to know what Kieran was talking about, this driving of cohort strength. We want to know what happens in that first year of life. And that's really hard to do. We want to track those group 0 bass all the way back through to the feeding grounds and the spawning grounds. So how do we do it? I will tell you, hopefully. So our study aims here were really to understand that connectivity between these nursery areas, from newly settled sea bass all the way through to adulthood, and then also to quantify the contribution rates of each estuary. So i.e. kind of like their value. And so this is how we do it. So you'll be actually familiar with these kind of things we call archival structures anyway. Your hair is constantly recording kind of what you've eaten and drunk. Tusks of walruses, shells, claws, and so on. They're kind of like flight box recorders, if you will. And what we tend to use are these ear bones of fish, otoliths, and now increasingly also eye lenses. The eye lenses effectively reflect what the fish has been eating, their diet, and then the otoliths are effectively reflecting water chemistry. So this gives us a lifetime kind of information. So just to underscore the importance of nurseries, when you look at this kind of typical survivorship curve, of any marine fish, it's quite similar for bass. You're seeing that actually we've lost around 99% of all of our fish in that first year of life. So that's pretty big change, right? So then there's only so much you can do with banning fishing. You can make more adults by banning fishing. But imagine if we could improve the quality of those nursery habitats and improve survival rates in that first year of life. We could have huge numbers of more adults in our sea. So that's kind of where I'm coming from. I'm really interested in that kind of restoration of our estuaries. So conceptually, there's different ways that we can use to kind of understand the kind of quality of these nursery habitats. Rachel Turnbull will be talking about this as well. You can look at, do we have more juveniles there? Do we have higher condition of those juveniles? More food in their stomachs? Do they have faster growth? And those give us proxies that we think will relate to survival, but it could be that numbers aren't perfectly correlated. You might have loads of currents dumping loads of group 0 bass there. Maybe none of them survive. So the gold standard is to look at the contribution rates to the adult stock. So the way we're doing it, we get these little baby group 0 bass in nursery area, blue one and a red one there, and we look at the outer edge of these archival tissues and we look at their genotypes and we can characterize the baseline. And then we look at the adults and we look back in time to those same layers of growth. And then we say, where are you from? Now, this particular adult was from the blue nursery area. We do it lots of times. And then we can say, okay, 90% of them came from the nursery area blue, 10% from red. And it gives us this idea of contribution rate. So where are we at with the project? Sorry, it's quite a busy slide, but conceptually what we're doing, we build the baseline, we catch the juveniles like Howard was talking about, we build these kind of assignment models. Then we say what we're doing now is really testing them. How good are they? Are we able to, do we have to do this every single year? Does it change much between years? It's obviously quite expensive to do. Could we just look at salinity models and predict what these otoliths and islands should be doing and so on? So we want to know how accurate we're doing. We're kind of there at the moment. And then once these juveniles recruit to the adult fishery, we then say, where are you from? So this is where the software science really comes in. So we're sort of doing pilot studies at the moment, but ideally we really want to start this in properly around 2026 when our 2022 group 0 bass recruit. So that's when we're really going to be pushing hard for fish. So then we'll estimate the contribution rates of these different estuaries. So that's ultimately where this is all going. And then we've got some preliminary data to show you today. So here I'm showing you, this is an otolith from a juvenile group 0 bass at the top. And you can see this kind of raster here, what we call a raster, where we've lasered the edge of the ear bone. And that tells us the estuary site. Now we're also peeling this tiny little islands at the bottom left there, and we're getting the outermost material, and that tells you kind of what it's been eating. So these are like kind of baseline, and then also the work that Howard was doing, the genotyping as well. That gives us another way to try and assign these individuals to their estuary of origin. So I won't leave you too long, because I know we haven't got a huge amount of time, but you can see conceptually how it is, just peeling a tiny onion. So then we look at the kind of element concentrations in the otolith and the isotopes ratios in the islanders. And in the adults, we basically do the exact same thing. We just go back further in time. So here you can see effectively where we put the raster on the adult otolith. And then we also, because we want to look at the whole lifetime of information, we also do this laser track across all the growth rings as well. And we're hoping to see whether we can use this technique to effectively give the same kind of information that we get from data storage tags. That's a bit more experimental. Cool. So some preliminary data. It's a lot of information there, but the take-home message is from, say, strontium and barium and otoliths, carbon and nitrogen isotopes, we are seeing differences between estuaries, and that's a really good thing because we need that for this method to work. So it looks like the method's working, which is great. What we're also seeing is we're seeing differences between the kind of inner and outer sites within an estuary, saltier, fresher. So this kind of also tells us that we need to maybe sample a bit more within these estuaries to get a good kind of full estuary signature. But it also tells us those group 0 bass are not moving around much because these are dynamic systems, but they're still showing these differences between those sites that we sampled. We're also seeing in some estuaries a poo signal. So the nitrogen seems to be elevated in the inner sites where they're closer to kind of sewage outflows. And we've noticed in the Medway, the Blackwater and the Colne so far, but we're going to investigate this further. We can't say for sure that it's sewage. It could be other forms of effluent as well. But just to say this is something we're taking quite seriously, obviously. Take-home messages from me, because I'm a nerd. I think it's exciting that normally people just use otoliths, but adding in the island is really, really helpful. So moving forward, I think we need to kind of like show the rest of the world our bass research, and everyone should be looking at eyes as well. And then also just again, pilot data. Thank you to Robin, Mike, and Peter for these 3 otoliths from adult fish. These wiggly lines basically tell the full chronology of these elements across from when they were born to when they died. And you can see the kind of low strontium and high barium at the start of the profile. That's when they were in the estuary. So you can kind of see already when they're moving off from the estuary when they're kind of growing up. And we may also, those kind of increases in strontium on the left-hand side might also equate to kind of maturation. So we might be able to get some physiological information out of these as well. This is more kind of experimental, as I said. So this is what we're up to. Moving forward, we're going to try and improve the baseline and really test it really well. It would be great if we could just predict these kind of signatures from things like salinity maps and so on. Don't like, killing juvenile fish, obviously. We also need to apply this baseline properly. So this is where surface science becomes really important. And then finally, working with the people at CFAS as well, using their data storage tag data to try and integrate all this information. So we've got from across the entire life cycle, both the kind of juvenile nursery ground usage, but also where they're moving as adults. So I think that's all I've got to say.